Okay, now question number 3. You're given, at the start, you're just given this. You're just given the position and the time of the jet. So at time equals 0 seconds, probably, yeah, it's seconds, I remember. It's seconds. At time equals 0 seconds, the position is 0 meters. At 1 second, it's at 75. At 13 seconds, it's at 858 meters. It's traveling horizontally, by the way, the jet. So it's the x position. And it's traveling in the positive direction, or it's assumed to be. Because, well, these aren't negative, so yeah, it's traveling in the positive x direction. The first thing you're told to do is just to plot it, the time and the position. Time is the independent variable, or it's a control variable, actually. So you can plot that on the x-axis. The plot command looks like this. Plot x, y. And you can find that on the documentation. A good skill to develop is reading documentation for programming languages and libraries. First, programming languages, because it's good to know the syntax. And the thing about most languages is most of the time you're going to be reading documentation on libraries, because libraries are what gives you the commands. In MATLAB, they're called commands. In every other language, they're called methods or functions or routines. And this is in the standard library, or probably, I don't know if MATLAB has a standard library or what, but it's part of, you can think of it as some sort of standard library. That's what it is. Every language, or I would assume every language, has a standard library that includes basic commands or methods. So this is included in MATLAB. You don't have to import any libraries to use this. And you can just find it on the MATLAB documentation. You just look up MATLAB plot, and you'll find the parameters. So functions take in parameters, or they take in arguments, actually. The function itself accepts values that are called parameters, and then whatever value you pass in as those parameters are called the arguments. So the arguments that I'm giving to plot is, for parameter x, I'm going to pass in the argument time, which is this array. For the parameter y, I'm passing in the argument position, which is this array. And then the function knows, okay, the user wants to plot. Since they passed in the argument time for the x parameter, that must mean they want to plot time on the x-axis and position on the y-axis. Then you do quadratic fit. So if I just called it fit polynomial, I didn't really know a good name for it, but you use the command polyfit. You pass in the x and y, and then 2 is just an enumerated value. If you keep taking programming classes, you'll learn about something called enums, or enumerated values. It's just an easier way to keep track of certain things that you enumerate. Maybe I shouldn't have brought that up. That was a little confusing. Don't worry about it. 2, if you pass in 2, it makes it a quadratic fit. Quadratic fit x, this is just converting, or it's making the domain. It's making the domain for the line that I'm going to plot. And that's just a linear space from the minimum time to the maximum time, which is really, I could have just said 0 and 49, but this is a more it's more dynamic. It's a more dynamic way of doing it, because maybe I want to add on to this. Maybe I add on a new data point. Then I don't have to change this, because it'll automatically go to the maximum, which is going to be the new value, assuming I keep this in increasing order. Actually, no, because max just picks the biggest one. So really, it'll like auto sort it in a way. Not really. And then 100, I don't even remember what that does. Oh, it creates 100 data points. So the step size would just be the length divided by 100. And that's a linear space, so it's just an array, regular array of values. Then the quadratic fit y is the value of the fit polynomial evaluated at each x. So this is kind of like evaluating a function. Evaluate this function, because this is a function. Evaluate it at all of the x values that are inside of here, which is just going to be a whole bunch of x values in between 0 and 49, 100 of them to be exact. And it creates those, it evaluates those, finds those y values, puts them in a new array called quad fit y, and then I plot that. I plot the quad fit x and the quad fit y. The instructions say to do it with the or you said to do it with the O. The what's it called? The line specification or whatever. Then you need to find the time at which the jet has half of the initial velocity. So first I just found half the initial velocity, that's 76.2 divided by 2. The acceleration is given in the instructions. It's the leading coefficient of the quadratic, or actually it's, I don't remember, is it a quadratic? It's something like that. But the leading coefficient on the x squared term is negative 1.6, so that's the acceleration. Because when you do the derivative, that'll end up being, wait, no, whatever, something like that. You're given this equation. It's a derivation of Newton's kinematic equation, the one that's like a Taylor polynomial. Or actually, it's a Maclaurin series. The elapsed time, you just rearrange this equation, so time equals the final minus the initial divided by acceleration. So I have half the initial velocity, because that's the final. You're ending at the half the initial velocity, and you're starting at the initial, which is 76.2, divided by acceleration. That's the elapsed time, which ended up being, if I run this, it was, or not, or I guess I won't run it. How do you run things again? Okay, maybe I don't know how to use MATLAB. Does it have like an incompatible name? Whatever. It was like 30 or something. 30 seconds, I don't know. But then you need to find the position, so you plug that into the first equation, which is finding the final x, given the initial x, the initial velocity times the time, times half the acceleration times the time squared. You plug that in, and you just get the position, which is the final thing you need. And you need to graph, or you need to plot a horizontal line using that. You just do y line for a horizontal line, and then the wedge, and then the hold on and hold off, that's for plotting multiple things on the same figure. If you want multiple lines on the same figure, you need to do hold on when you start, plot everything, and then hold off. If you don't do that, it'll just keep like clearing it and then plotting a new thing. But if you want them all on the same thing, you have to do hold on, hold off.